Okay, seems we are live. Hello, everyone. Good afternoon, good evening, good morning, depending on whichever part of the world you're joining from. A very warm welcome to this session, to this panel discussion with our friends from IIT Bombay and NPCI. We'll do a very quick round of introduction around the session, what we're going to cover, and everything. With me, I have Divyanshu. So, hi, Divyanshu.
Hi, Mother.
Hi. So let's start off with a quick introduction for maybe IIT Bombay and what WNCC and Institute Technical Council is. I see WNCC written in verse in the background, but if you can give an introduction, that will be great.
Sure. First of all, hello everyone. I'm Divyanshu, and I'm the Institute Web and Coding Secretary at IIT Bombay. And telling in brief about WNCC, we are the tech club at IIT Bombay as a part of the Institute Technical Council, and we facilitate things between absolute beginners at IIT Bombay and students who are very extreme veterans at IIT Bombay. So basically, our aim is to bridge a gap between beginners and experienced coders. So that's what we provide at IIT Bombay, and that's what we are aiming with this session also.
Okay, nice. For Pathway, I think since we also have Adrian on the call, and for NPCI, we have Jay and Meg, I think it will be best if they can give a quick introduction. So let me quickly introduce them so you know who they are, and then we'll loop them in because we are here to learn from them, their experience, and also ask questions to them. Or probably a good set of interesting, funny, contradictory, or challenging questions. Let's see. So, by the way, let me quickly loop them in and start off with their introductions. That's Jay, Adrian, and we have Meg. Okay. So welcome everyone. Hi Jay. Hi Meg and hi Adrian. Thank you for
Hello,
being
Madhu.
here.
Hello,
Hello.
Divyanshu. Hi, Trian. Hi, Jay.
Hi.
Hello,
Hi guys.
everyone.
Hi
So
Jay, Divanshu.
for those who do not know, Jay Prasad is on Pathway for the second time. He speaks very proactively in the AI community. Um, and the last session that he took recently that I also attended was at IIT Kanpur and BHU. So Jay Prasad, by the way, is the head of data science and AI initiatives at NPCI. Uh, NPCI, for those of you who do not know, it's the maker of UPI, IMPS, and a ton of crazy products out of India, which are processing over 14 billion monthly transactions, which is an insanely good number. And needless to say, from like the background that he has, he's in a way shaping the fintech ecosystem in India and abroad, wherever NPCI products are being established. His interest lies into fraud modeling, computer vision, graph AI, NLP, and all. And he's an alumnus of University of Mumbai as well as UC Berkeley, where the Haas School of Business. So thanks for being on the call, Jay. Apart from him, we have Adrian. Adrian is the chief product officer at Pathway. Did his PhD at 20, which is a cool thing. Then he taught at Ecole Polytechnique for more than a decade or so. He was also into industrial research for 15 years or more. He co-founded Spot, which is like the way I call it in my imperfect language, is the OG competitive coding platform, which impacted a few million developers around the world. So we have Adrian. His expertise, by the way, lies in distributed programming into advanced algorithms, and also he's quite relevant around streaming himself. And talking about streaming, the next person that we have on call is Meg, who is a solid hands-on streaming practitioner. He's currently a data engineering specialist at NPCI, works out of Mumbai, I guess. And then his expertise is into big data technologies. Previously, he was an AVP at Pentation Analytics. And this is the second time, I think, in the past 2 months or so, when Meg is back at IIT Bombay because he recently took a session on fraud modeling there. So I think a lot of faces from the campus, Powai campus, might already know him. So I welcome you all for this session. Thank you so much for joining in.
Thanks, Mudit.
Thanks, Madhu.
So maybe we can quickly start off. Maybe Adrian or me. Let's start off this way. So Jay or Meg, if you would like to take a shot at quickly sharing what NPCI is for those of us who do not like a brief description for those of us who might not know about it. And Adrian, if you can share what pathways, that will be helpful.
Right. So maybe I can go first. So NPCI is, you would probably know for Indians, NPCI is a well-known entity, and it's responsible for the digital payment ecosystem, right? Largely, and it's, you would see our impact probably countrywide, and we affect the lives of every citizen in the country through products like the crown jewel UPI, for instance, which dominates the digital payment scene right now, or things like IMPAS, which is mainly for enterprise-wide business, for instance, or even things that we take for granted. For instance, maybe while crossing a toll plaza, for instance, you don't even know that NPCI is the company which is working behind the scenes of something like a fast tag, for instance, or something that is taken for granted, like a check clearing system, for instance. We are responsible for that too. And every time somebody pays a utility bill, for instance, either through a Google Pay, Phone Pay, Paytm, what have you, we are behind the scenes on that front too. So you can clearly understand the kind of impact that we have. We work with very large systems, and it is within the culture of NPCA to build a lot of these systems from the ground up. Right. So we are very proud of the open source investment that we are doing in this particular ecosystem and building almost everything from scratch. So we get the hardware and we set up all the stack on top of it. Uh, so towards that front, we have several things that need to happen. You need to take care of large amounts of data which need to be either ingested, computed, processed, and so on. You need to have a robust system for storage for that kind of data. You need to have a robust system for very low latency inference, right? And you need to have a robust system for querying into that data. Right? A lot of those systems have been built in-house from the ground up, and this is not of any cloud. This has been built into our own data centers by our team. So folks like Meg have been quite quite a leading part of that journey, right? Uh, and it has sort of allowed us to have our own perspective on how to build big data systems and how to serve it without any dependency on a public cloud provider, for instance. So that's a very quick brief of where we stand. But suffice it to say that we now have expertise into building large data platforms, large AI platforms, large data engineering platforms from the ground up as a part of this team. Adrian, over to you.
Thank you, Jay. So I'm here for Pathway, which is a technology company set up about 5 years back by folks who'd been working at the same time on enterprise projects in a variety of companies dealing with live data, and had passed through academia, Google Bain, places which were more oriented towards machine learning and algorithms. And the place where it all started out was about understanding how to make it easier to bring together data that's changing, streaming data, live data, and machine learning transformation. So today we're happy to bring to the market a software package, a solution that you can use as individual developers that allows you easily manipulate data that's changing over time and to perform transformations which are the data science machine learning type on top of changing data, and also to plug it together with external systems and APIs and external services. So today, in the world where we are today, indeed, there are like amazingly powerful large streaming platforms, but maybe as we discuss in the course of a panel, there are also some smaller, lighter weight applications which call for streaming or where streaming may be beneficial. So somehow bringing this ability to build an end-to-end system that's capable of streaming data also to potentially smaller organizations or smaller data teams in large organizations is something that we focus on. And in the context of what you can try to do today as students, as professionals, as individuals. It's also something we aim to bring is this ability to start your journey into streaming with technology that's powerful enough to take on streaming data and also to allow you to do streaming data transformation.
Okay. Fantastic descriptions around Pathway and streaming. I've understandably it is normal for me to say I'm a fanboy of both the companies. Um, I have known Adrian since like as a figure in the competitive programming space. Uh, he was definitely a popular guy, and Jay he has been speaking for a while. Meg and NPCI. It's kind of mind-boggling if you look at the products that they power, and the numbers that if you go to NPCI's website, you will see they mention some stats. You would initially, in typical websites, you may assume them to be numbers of users, but they are number of banks using their platforms, and that is just crazy. Like they have enormous scale. So let's get right into it. Divyanshu, why don't you start off with the first question that we have received from our community? So for those of you who do not know, we have received some questions beforehand, and we'll be putting them across. These questions are going to cover a realm of around like the streaming spectrum. If you look at it, we'll start off with introductory questions. We'll cover the current landscape. We've ordered the questions in a way so that it forms in a easy to follow manner. And then towards the end, we'll try to understand what's ahead of us, what's something that you can do as a researcher in this field. And of course, if you have any questions as you're watching this live, you can put them across in comments. We'll be having a look at it during the session itself, and we'll definitely try to pick up towards the end. So yeah, Divyanshu, over to you. Sorry, by the way, you're on mute.
Hello, sorry. Thanks a lot, Mudit, and thanks a lot, Adrian and Jay, for the descriptions. So, without further ado, let's hop on to the first question. So, let's begin with a quick introductory question, which is what exactly is streaming? So, we understand that data processing might be about processing data at scale and doing some transformations. But what exactly is data streaming? For the students who are new to this domain, is it like video streaming? So let's, if you can quickly describe, how would you all creatively explain streaming if you had to do?
Maybe you want to take that?
Sure, sure. So, thanks for that question, Divyanshu. So, I mean, if we look at traditionally, right, before the advent of internet or large scale systems, right, where a lot of users had to use the system and all that, right. Traditionally, there was one backend team which was used to handle the data, and I mean that has continued till last 10-15 years, right? That there is a team which handles the data which is coming into the system backend databases, and they are the SMEs on the data. They know what each data element means and all that. And if you need any insight from the data, anything, you need to ask questions to the data, right, to understand about your business or anything, right. There are a few people who know the data in and out. They would query the data and they will give it to you, right. But with uh, the uh, advancements in uh, advancements in internet access and all that, and with the amount of data that is being generated every day, right, uh, keeping the control of data with only a few set of people generally results into bottleneck for the organization, right. So organizations gradually move towards open data democratization, right. And with that, a new avenue opened up that most of it, historically the technologies had been that there was a OLTP database. I mean, there's a transactional database, and then there is a data warehouse where at the end of the day, the data comes from the transactional database to the backend data warehouse or data store, and the users have visibility of T-1 data. I mean, data state as of yesterday, to see what is happening in the business, right? But that is again, I mean, once people started using it, people started having that capability. They wanted more, right? So they wanted the data of what is happening right now. I mean, what happened 10 minutes back, or what minute happened 5 minutes back, right? So that is where the advent of streaming um, happened, right? So stream data processing, and that is where I think even apart from data access, it is also about quick decision making, right? So if you are basing your decisions on let's say a data which is stale for 15 or 20 hours, right? It doesn't tell you what is happening in last 15-20 hours, right? You need to see what is happening 15-20 minutes back, right? So a lot of applications had this demand to have a fresh set of fresh uh, data, right, to make quicker decision making. So that is where the birth of stream data processing happened. And again, it is related to the video streaming and audio streaming as well. uh, but that is again through content delivery networks and all that. And uh, that is also one type of stream data processing. That is one use case. Adrian and Jay, you guys are also the stalwarts here, so please feel free
So
to add.
yeah, Adrian, if you don't mind, I'll go in next. So I think the most common overloaded use of the word streaming is when somebody uses it in what Netflix or Disney
Yeah.
Hotstar and stuff like that, right? So you're not wrong there in associating data streaming with those content streaming services, because some of the backend technology is quite similar in nature. But data streaming is fairly broad based, right? So we are covering media streaming, we are covering like data streaming, like the ones that Meg is talking about. But the keyword that I want to leave with the audience is immediacy, right? The nature of the data that is with you as a consumer is fresh. It's immediate. It has come from the source immediately, right? And you can relate to that to several different avenues, whether it's video streaming, whether it's streaming from an OLTP database, and so on. So it used to be the case that people used to fetch data in, like, I think, figurative trucks, for instance. But now it's more like a big pipe which is flowing. Of course, there's still trucks being used to transport data, but that's at an exabyte scale. So if you're just to leave you with a small anecdote, if for people who don't know, once you move to an exabyte scale, even all these streaming technologies become quite expensive. So Amazon has this concept of transporting a large hard disk, which they call a snowball, in large trucks, which they call snowmobiles, from home, and they'll send it to you. You upload your data on it and send it to Amazon's data center. But that's a story for another day. We are not going to focus on that. We're going to focus on the here and now, where the data is available to you immediately and it's coming from the source very quickly. So you can take decisions very quickly, like the ones Meg is talking about, right? You can either query on it quickly, understand what are the signals which are approaching, understand, or even view your video, for instance. Or you take decisions like fraud modeling decisions, for instance, which we tend to do on our side. So just to give you a quick gist there. Adrian?
This is a great introduction, and maybe one thing that I could add in terms of keywords. So Jay, you mentioned the immediacy, the freshness. The one thing maybe that's good to think about is the kind of data that comes in streaming, because it's true that like being used to Netflix, we're kind of used to streaming video, streaming audio, and you can well ask, what else is there that you can do streaming for? So it's not so much of a surprise, being here with experts in financial data processing, but you can think, transactions, large volumes of transactions. This can be a streaming system. But very broadly, another type of data is events. So there's a lot of streaming of events data, which is about things that happened. It can be like you send a text message to someone else. It's an event. event, you click on a website, it's an event, you do a transaction, it's an event. So this type of data is also being streamed, and there the term is used also to do like streaming of large amounts of data coming in from different sources. So you're running your web server and there's lots of data streams coming in of usage, but it gets a lot less beautiful than just a stream of video. It's more like, you know, a river with multiple currents and lots of different, you know, whirlpools and things like that. So it gets a bit turbulent at times, and in particular, you know, if you send emails to someone, you know, that the emails can come out of order, and like one can arrive after another, a bit delayed. Same for text messages. So these are types of challenges that are very pertinent to streaming systems, and the topics that we all try to address: how to make sure that these streaming systems get data that's fresh, and how to control these little issues with things arriving not quite as they should.
Okay, thanks for those descriptions. And like trying to understand one key thing as as somebody who interacts with academia quite frequently. So technically, if a college student is seeing that the ETA in their Uber or Ola app is not correct, it's because people from this particular panel from the similar industry are probably trying to work and make it better. They're still in the process.
My God. Mudit, you'll have pitchforks for us very soon.
So, let's see. Yeah. But there's another question that is very interesting, like just trying to extrapolate further. That fair enough. This is where streaming is. You actually, we as I saw that the description that May gave, then Jay followed on, Adrian gave. We covered multiple aspects around practical issues with it. We covered what is it really, and then where it, started from, the genesis of it, where Meg started answering it. But what's the current landscape and where is it headed? Like, can you give some perspective? And one special question to like Meg and Jay also, which is like specific to Indian context. Is there something that you see differently as to the global context? So yeah, maybe
Yeah.
anyone who could take it. Yeah.
So, in the Indian context, again, as I said, right? So, mostly, even if you see right now, right, most of the industry, uh, I mean, 5 years back, the batch data is what people are relying on, right? And even today, I mean, the if you look at the companies who are adopting streaming as a mainstream data source, right? That would be a handful. I mean, would be mostly uh, less than 10%, right? But most of the companies are relying on batch data only, right? Because even running the streaming systems, right? I mean, it's a big commitment, first of all, because you have to, since something which is streaming in nature, you have to ensure continuous uptimes for that. You need to ensure high levels of availability. You need to ensure for that requires investment. That requires investment of resources, hardware, software, even people, right? So not everybody is ready to take on that journey. I mean, and not everyone needs it also. I mean, it's not a bread and butter for everybody, but the companies or organizations who need this, right? I mean, uh, companies who need to make quick decisions, right, based on the fresh data. That is where this thing comes in handy, right? This particular methodology of data processing. Yeah.
Okay.
So I would say that I mean less than 10% in the Indian landscape. I
Okay.
mean, and that too in IT or IT services. I would say not even and fintechs, not even talking about other companies.
Interesting perspective. Yeah.
I'm with you, Meg. If I can say something, like the 10% figure is one that seems to stick in my mind too. That somehow like 10% of the use cases are streaming, and thanks for this like great perspective as well on systems. One thing maybe is that, you know, you can sometimes think whether you are forced to use streaming because you're
Yeah.
kind of setup requires it, or whether you choose to use streaming. So sometimes you're forced to do it because just the
Yes, yes.
latency, the requirements are there, that force you, and sometimes you want to do streaming by choice, and it's actually super interesting
Mm.
setup when you would want to like process data when it arrives, because it's just less expensive or more convenient, despite all of the issues that you mentioned, Meg, with high availability, with maintaining systems like this. Sometimes it just sort of spreads out the work better. So, for example, if you use an API to process your batch data, think you're using, I don't know, OpenAI to do something. You probably don't want to send like thousands or tens of thousands of requests to the API, because it'll slow down or you'll get banned or something. So you want to spread it out a bit. So it's kind of like sometimes
Correct.
sometimes there's some advantages to stream processing, and in different contexts, folks adopted by choice.
I'll
Exactly.
just add a thought here. I think this is also a mindset, right? Like both Meg and Adrian are alluding to. This is a fresh mindset for a lot of people, especially in India, right? Of course, meaning when you're talking streaming, you are talking about broad context, and I don't want to reduce the context to only like Kafka streams only, because there are other streaming version, etc., or etc. But I think it's a mindset and it's a choice here. It's a design choice. Are you ready for it, for instance? Uh, and it's a mindset in the sense that even if you're ready for it, are you ready for it as a coding lifestyle or a data processing lifestyle, for instance, right? Which is very different from the way that you generally do batch or anything else. Right? I mean, if you're fetching large amounts of data, I think there is a set procedure there. There will be set procedures there. People are very comfortable with it. People understand failure cases. People understand edge cases. But when you deal with streaming as a way of life, you need to be aware of what things can go wrong. You need to have your data operations team in place so that people are just constantly patching up as things go wrong. Right? It's not, you can't wait for something to go bad, and you need resiliency built on your side, just so that you are aware when things go wrong, it's been taken care of. So it's a complete lifestyle change in a manner of speaking when you take that over, right? uh, and the team has to adopt from like a batch engineering to a stream engineering, that they are now aware of the edge cases. They are prepared, maybe slightly over engineered on the consumer side of things or on the recipient side of things, and maybe they keep track of what has missed, what has been missed, or what should be brought back, for instance, what do we replay here, and so on. But it's a very different kind of team mindset. You would see, like these gentlemen alluded to, I think the past 5 or 6 years has been very uh, instrumental since the arrival of your your actual video streaming services, for instance, because they sort of spread that message, or even the social media platforms which have entered India, right? Although we see streaming from the consumer perspective, which is the citizen on the street kind of perspective, but the behind the scenes perspective is equally as interesting, and they have sort of spread the word about what makes sense over here. So
Okay, that's a very interesting perspective that you share here. And I have a very quick follow-on question, Divyanshu, if I can take it, which is slightly along the lines of what you mentioned. So you mentioned it's also like a lifestyle, an interesting way you put it across, and this is quite understandable that because that this is this newer realm where only 10% of companies who probably want to jump onto the curve, they are still on the process in the process of it. So I'm wondering, in a practical sense, this would also pose problems where you have to manage all the batch workflows separately, which are like the traditional, the current ways in which we operate, and then the newer realm, which is around streaming. So, are there any strategies that you have seen around managing these two separate workflows better? And is there any, like, do you think a unification of these kind of two workflows would even make sense?
is the question for me or Adrian or Meg?
Um, yeah, anyone can take it
I
there,
can I can
Adrian.
I can jump in. I can jump in with a quick
Sure.
comment with it about the a very subtle distinction, which might be interesting, especially if someone is like basically out there on the job market. It's I wouldn't say it's exactly the case that 10% of companies have streaming use cases. I don't know how many percent. Definitely, if you look at like the Fortune 500 of the larger players, about 80% plus of these companies do have streaming teams in them. It's just that these streaming teams are somewhere, and they do a part of data processing. They're kind of somewhere plugged in the organization, and depending on how the organization is set up, they're more or less isolated. We can discuss why this isolation sometimes happens, but you don't actually hear so much about them because there's not so much transfer of know-how, of code, etc. There are multiple questions also, of technology stacks, of different choices of tooling. Sometimes they just some teams don't talk to each other, so there are multiple reasons for it. But maybe very directly to your question, Mudit, there's one point which is kind of trivial, which is interchangeability of code base. Can you actually do things with a shared code base between a batch team and a streaming team? And this is a pain point. This is a pain point which we observe quite often, that like it's super hard to define a function in such a way that it'll serve both teams well, and obviously like pathways among those who are trying to overcome it, but it's obviously a recognized pain point for with Flink, with Spark solutions, with solutions there that are meant to address it at least partially.
Okay.
I'll just add a few things here, and maybe Meg, you can hop in as and when you see fit. So for us, the journey has been that of necessity, right? We want to see things which are immediate in nature. Uh, I don't have prescriptions which are like industry wide, but we can share learnings that we've sort of accumulated along the way, right? Things, for instance, we were quite a happy bunch with batch engineering too. It's not like that, right? But along the way, I think we started getting questions and started getting demands for much more urgent queries, much more immediate queries, for instance, which means that either you speed up your batch engineering by some magic wand, or you figure out something which is slightly uh, long term in nature, something like a stream engineering, for instance, right, for your mix. A second facet for us is we had to take decisions also on incoming data, for instance, right? And which means something current is always required. So these two forced our hand into moving towards a stream engineering perspective. But the two engineering teams and the two tool sets and the two tool chains still remain, like Adrian said, they're slightly different, uh, but the purpose is very different for each of them, right? One, for instance, is a stable stream which you know what you're getting as input, you know what is to be expected as output, for instance, on a daily basis. You can run like policy procedures against it, for instance, which is your batch engineering kind of a data, for instance. And there are much more urgent related demands, for instance, which can be serviced of like a stream engineering pipeline, for instance, right? Uh, but of course, the code bases are not going to be identical. So you'll have different code bases, different teams, possibly with different skill sets also. And the kind of challenges that are being posed of both of them are going to be slightly different. I'm not sure in the next 5 years whether they're going to diverge too much or whether they're going to be basically merged into one large team. But that's certainly a way that we are headed.
And in practice, have you seen it kind of pose any problems where the streaming teams are working differently? One assumption that I can make as of now is that naturally, since the workflows are different, if any change has to be done, you have to have to put in kind of a double effort in a way. So, does that kind of pose any challenges? Any practices that you have seen that had to be specially put in to be able to mitigate this bit?
So it's less about double effort and more about the requirements of the story. Right? If your requirements of the story, I think you should not engineer for the heck of it. I think because these are like data engineering pipelines are fairly heavy, uh, generally heavy. At least in our case, are like super heavy, right? But uh, I think it's usually said, right, measure twice, execute once, for instance, right? I think that strategy applies here. uh, and it's an investment, and you have to consider the investment moving forward. If there is a need, as is the case for us, for instance, there was a need. We had to take steps towards it. Uh, we we had to take steps towards creating both a team as well as a necessary tool chain to execute it. But I think every team to its own, so each team to its own, they have to take a call here, and that call has to be both tactical as well as strategic in nature. If you're going to solve it, are you possibly re-engineering for a cause, or is it re-engineering just because you like it? Right. So there are two different things.
Okay, makes sense. Maybe we can, if Meg or Eden, you don't have any additional comments to this, we'll pick the next question, uh, which is an interesting one coming from a practitioner's lens. If you look at it, Divyanshu, would you like to pick that up around the considerations bit?
Yeah, surely. So I would want you to throw some light on what are the key considerations for in streaming. So what are the most important considerations for a data practitioner at a large scale, like the ones you have dealt with in your journey throughout? And is it the ease of use? Is it consistency? Is it lower latency? What is it basically?
May, May Adrian, nothing up to you.
I couldn't hear the question. Sorry.
Yeah, surely I'll repeat that. So the discussion is
I'm not
about
able to
the.
hear Divyanshu. I don't know whether it is only me.
Could
Hello,
be at
I'm
your.
not.
I don't know. I'm able to hear everybody else, but not able to hear Divyanshu.
Okay, I'll try to tweak the question and put it across. Maybe Divyanshu can try reloading in the interim. So typically this is more from the lens of picking a streaming framework and understanding like what are some of the considerations that you should look for. And if you have any relative priority, for example, it can be ease of use, like ease of use of
Hmm.
the technology. And it will be interesting to know if this at all is a practical statement to make or not, whether this is in practice easy or not. But yeah, ease of use, consistency, which seems to be an important topic here, because Adrian mentioned about out of order data a while ago, and other issues which are around practical implementation. Then this realm of lower latency, where we see F1 teams using frameworks like Pathway to have data processing happening in a very low latency. Is that something which is important? And cost. So if you would want to share, how would you look at it at these factors in terms of their relative importance?
Understood. So, if I had to take, can I take that question? Yeah. So, I would place importance on a few factors. One is fault tolerance, right? So there is, I mean, whichever system or framework you're using, right? That has to be inherently fault tolerant in terms of replication, and even there has to be what do you call as horizontal scalability. You can add more and more firepower to it and make it horizontally scalable. Uh, the framework, and so it has to be, I mean, horizontally scalable in terms of how many instances you are adding to the framework, right? In terms of hardware and all, right? So scalability is one, fault tolerance, then also security, right? Because we see a lot of importance nowadays around data privacy and governance and all that, right? So there have to be inherent in the framework that you choose, right? Security considerations, I mean, so be it authentication, authorization policies, or access control, even encryption, right? And isolation of data, right? All that is something which makes a good framework, which can be adopted enterprise wide. I mean, those are the considerations that I usually see. And also, I mean, it has to be again, yeah, I already took horizontal scalability. So basically, you can run multiple instances which increase your throughput of the increase the system throughput of your system, right? So those are the three important considerations that I would see.
Okay, interesting. The reason I actually picked ease of use earlier was because, well, recently talking to students at IIT Delhi and Bombay both, we
Hmm.
observed a few students were specifically kind of feeling glad to have picked a framework that was easier to learn, because traditional spectrum of frameworks, they use Java and they are not, like, we have to put in some additional effort to get superbly hands-on with it. It's not that they struggle in terms of picking a new thing, but then it's an additional effort and a separate framework altogether. But maybe Jay and Adrian, would you agree with the kind of considerations that Meg gave, or you have a different perspective that, yeah, and would you put it to ease of use, consistency, latency, and cost? I believe cost is something that is very important, but if you can share from your end.
I'm not going to disagree with Megan if you're trying to do that. So, uh, let me add like a few more things. I think what you are asking is also a slightly separate dimension, which is what is the comfort factor in terms of adoption, right? And that is different for every organization. That is different for maybe like a student who are open to Kafka streaming, open to pathways, etc., versus like a mature company who want to test out very quickly but implement something which is mature in nature and has support, right? And so the if you look at just a graph of how experimentally uh, sensitive people are versus where in the maturity they stand, for instance, you will see enterprises will take experiments but will go for something which they know is well adopted possibly in a community, and then adopt it, for instance. And you will have these questions about latency, etc., are all in the mix. They will Everybody will assess what is the latency like, what is the replication factor like, what is the resiliency like, what is the scale out like, right? And they'll make a call, and you'll possibly find competing tools, maybe uh, pathway and Kafka, etc., for instance, all having similar factors in nature, in which then the organization uh, or the individual, they have to make a choice about what do they pick next, what makes sense for them, etc., right? No easy answers there, but the community will define what the organization or the individual picks, for instance. So if, for instance, friends of Jay and friends of Meg who are in the community, who are well established maybe in Kafka or Pathway or etc., for instance, we look at that dimension a lot more seriously, because you know that there is an expert around who can help you here, who can lend a hand to adopt it, right? And maybe if somebody is doing something in F1, maybe they'll reach out to you, somebody like you, Mudit or Adrian, right? Because you have experience in that sense. So a slightly mixed answer, but the second part of the story is also interesting. You talked about Java as maybe a bottleneck for some adoption, etc. I think that plays a role for maybe not organizations, but individuals who, uh, especially in the current generation, right? They want things which are snappy, which are more Python friendly, for instance, right? You would rather see somebody headed towards that rather than like something like a Java or a Scala. But that's a separate dimension, and that will still remain, and you will see very interesting choices coming on based on those factors as well. So the current generation will define how these choices and how these tools also shape up. But I think it's a matter of figuring out, charting out all the tools and which tools are the best for that organization or that individual here. So organizations have a slightly different way. I mean, they go about doing a thorough job and then picking something out.
Interesting. And yeah, that is actually kind of, I think, also reflected when we see these frameworks coming. Even Pathway does this, where it is underlying engine is on Rust but exposed by Python.
I should say I'm very much with Jay on a lot of points, because it's and Meg, I believe you're also quite right. I mean, and in terms of the case of what organizations and how decisions are taken, this is so much dependent on the team, the use case, the preferred data setup, the requirements, that there are many like right choices in different situations. And even terms like ease of use or things baking can mean different things to different people. So maybe I can just give two very concrete examples. So when you have ease of use, it's ease of use for someone, and it's not like in a large scale streaming deployment you have the one developer who is affected by everything end to end. You'll have the ease of use for the developer who's developing the code, the developer who's maintaining the code, and the persons who are actually managing the cluster, ensuring the site reliability engineers, all kind of folks who are there. So actually, we see that there are, like, for example, two different deployment methods that may be preferred depending on an organization. Either having one cluster that's running like Kafka, Flink, etc. Then the kind of the developer who's developing new pipelines is more like the client who has to go to the cluster and ask for their job to be run, whereas the cluster maintenance team has things harmonized and more in one place, or more than like a distributed ownership style in which everybody kind of owns a smaller deployment, a smaller like container, a smaller cluster for every different use case, and has kind of control over bits and pieces of the setup. And depending on the organization, one may be preferable or the other, depending on, for example, how autonomous the use cases are, whether pipelines are developed in a way which powers multiple use cases, so you become part of the data platforming. And if you build up a data platform that has many like use cases on top of it, or if you see streaming pipelines as feeding one or two use cases individually and being more autonomous. And Jay, I don't know if you want to add something here, but we've seen both in different organizations and different scales. A lot depends on organizational approach, also on the way data teams work in organizations. Sometimes machine learning teams specifically like to be like end to end and own the use case. Some data engineering teams usually prefer to build platforms. So
Yeah.
both come up.
So it depends on the kind of streaming that you also have. Like maybe it's streaming in the large, streaming in the small that we were like chatting about earlier, for instance. With large scale data stream, I think you would possibly, at least what we end up doing is we have dedicated team who are managing the show, right? The ingestion part of the show. But once you go to very small but very sensitive streaming, which are much more real time in nature, for instance, like your media streaming, for instance, that you do, the kind of tool chain also starts differing heavily, because now you are looking at lightweight streams. Of course, latency matters across, right? You have large data, but small, fast data, right? Latency matters across the board. But the kind of tool chains that are available to you start differing. The kind of people who are working together, that starts differing. So you will possibly see a data engineer with a platform, machine learning platform engineer working possibly closer on more like an edge streaming kind of a platform, for instance, right? Or IoT edge streaming kind of platform set. Or maybe like a media streaming, if you're looking at, again, those people will start coming closer to understand how do we ingest this, how do we infer it at a speed where it's coming in, for instance. Uh, and the further that you start placing an emphasis on how large data is, and should there be a special team for it, you'll start seeing some divergence in the way the team starts working, right? But you have different streaming use cases, and these will determine both the tool stack that you're using as well as the style of the team working. uh,
Hmm.
at least that's our experience.
Absolutely.
Okay.
If I can just add one thing, which actually was one of the more kind of eye-opening things, which I was kind of surprised about, is actually the requirements of like things bake, and it's natural things bake. So your platform bakes, your code bakes, the framework underneath bakes, your hardware bakes, everything can bake. But depending on the use case, there are different ways of baking which are more or less kind of painful. And one of the realizations that we had, we were actually engineering pathway to be, like robust in a lot of places and proposing like high availability setups. And then we noticed that depending on the use case, there were folks for whom this was absolutely essential and folks who didn't care that much. And especially, and rather surprisingly, the latter kind was often in machine learning systems alerting anomalies. And it took me a while to understand what was happening. And in fact, if you think about like a house alarm, you have an alarm system at home, and it's meant to detect, those couple of incidents a year, hopefully less, that are relevant, and it has like accuracy, a chance of detecting the intruder at say 90%. Then the fact that it's down for like 20 minutes or even a couple of hours every year doesn't change so much for you, because if in the worst case, your detection rate will go down from like 90% to 89.9. So you don't care so much about pushing the SLA up and getting this like fully robust if it's one of those systems that already is losing, is meant to be like 90% accurate to 90% good, but is prevent. Then you can kind of afford to have certain things which are like going down every now and then, and some folks prefer not to over-engineer, not to put in high availability, and we say okay, because indeed, from a business perspective, in terms of money lost, it doesn't change so much, and sometimes it can change a bit from a credibility perspective, because if you're not doing something for like 20 minutes and all your customers notice it, even if it's not a business pain directly, it can be a kind of image pain that it went down. So it's all very subtle, it's very use case dependent sometimes. Mm.
Okay,
Completely
interesting.
agree with Adrian there. Yeah.
Okay. And by the way, Jay, I saw you had unmuted, so you wanted to add something to this?
No, I think Avian sort of added that really well. I mean, it's general the shape of the entire data architecture which is going to determine the story, right?
Hmm.
So you have uh, a producer with a large fat pipe and a consumer, right? Meaning you can consider your large fat pipe as your either your Kafka or your pathway and all these things, right? Or the other extreme is small producers, lots of small pipes, and one fat consumer, right? Maybe, for instance, which can also be an interesting mix. And the kind of teams which are sitting behind each of those are very different. The kind of tool chain that is sitting behind each of those is very different. The kinds of sensitivities which are possibly present is something similar to what Adrian has mentioned, right? You have to measure what works there and how do you take it. Uh, how do you engineer for such these kinds of uh, scenarios?
Okay, interesting. Um, Along the lines of streaming at large, streaming at small, you mentioned about edge, working on media. Um, Divanshu, there was this question that we saw right around these cases. You want to pick that?
Yeah, sure. So, as they say, it's a generation, it's the age of AI, and you also took up the points like working on edge, working on media. So, what about you throw some light up on the use cases in of streaming in generative AI, edge, and media? So basically, these days, lots of students and professionals are working on edge and working on things like generative AI using LLMs, GANs, etc.
Hmm.
So, have you seen any practical use cases for stream data processing in these fields?
Yeah. Um, uh, can I go first or?
Yeah,
Yeah,
go
sure.
ahead.
Yeah, yeah.
So I think these are slightly different. Generative AI in the streaming world, edge in the streaming world, etc. So, for instance, if you want to use generative AI, I think you're looking at either a re-indexing solution based on fresh data which is coming in on a regular basis, and trying to ensure that your questions are most relevant or answered in the most relevant fashion, right? With generative AI, otherwise, for instance, you are dealing with a foundation model which is largely unchanged. But in the enterprise world of things, when question and answers become important, and question and answers become important on current set of documents, you would want some changes which are happening behind the scenes in terms of a RAG solution, which is being maybe re-indexed continuously at a cadence. And to re-index at a cadence, you need some input data, and to get that input data, you'd possibly have either a streaming solution or a batch engineering solution. Right? So you have that on the generative AI side of things, right? And I think Adrian can sort of add a few aspects there. On the edge is like I said, you have lots of small producers who are working on small pipelines, but together the destination starts consuming a lot more. Uh, so you will possibly have like two different sets of pipelines. One is pipelines for each individual edge, in which case lightweight, meaning uh, when we use the word edge, it's for a reason, right? It's to convey a bit of, it's not as heavy as the other systems, right? But to have like a lightweight system, you have to re-engineer very carefully or engineer very carefully. The data engineering has to be just right, so that you know what you're taking across, and it has to be absolutely necessary what you're taking across to the final consumer. The final consumer will possibly have its own pipeline, which is maybe a large fat pipe, etc. But still, there would be two different kinds of engineering here. Media is a whole different business, right? Media, if you're talking media, for instance, from a pure video streaming perspective, that is CDN, etc. We're not talking about that at all. But now your uh, producers themselves are generating packets or payloads which are fairly fat in nature, uh, and which means that the sensitivity of what is coming in needs to be preserved at any cost. Meaning that payload is precious, right? You can't really go back and ask the producer to say, please generate that payload again. No, that's not going to happen. So you're now, your entire data engineering system is now built to basically grab that payload and store it as early as possible, so that you can set up processes later uh, which will start working on it, right? So slightly different architectures for each of those three cases, but the kind of solutions that you will start seeing are vary a lot between these three cases. Adrian, Adrian or
Uh,
Meg, whoever
yeah,
can answer.
Meg,
No, I think I don't have any additional points. I think Jay summed it up very well. So
I've, I'm also aligned with Jay here. Maybe one thing that I could say is, like Jay, you brought up the question of re-indexing live data and data that's coming in with RAG, and indeed, streaming pipelines are kind of like an ingestion source for this kind of the data, the fresh data that's coming into the system. Some things maybe to be said here is that in a way it's a pity that foundational models, machine learning models, do not adapt so well to streaming data. So we resort to systems such as RAG. So this is maybe one point which I think will be alleviated in the next 12 months. We'll see more and more foundational models which are actually able to adapt, fingers crossed, here to fresh data. But even today, you can use actually, like, I wouldn't say legacy, but more traditional machine learning models which are able to adapt to changing data and to do analysis on just the last few minutes of data in case there's like a sudden data drift and you need to reshape your model to the current situation. So for non-stationary data, there's some things that can be done, though it's not being like massively rolled out. These are things that are kind of more on the cutting edge of things and of experimental. One other point is that unstructured data, and this is how we try to perceive it in speaking from like a streaming perspective, which is very much about events data. So we have started to have unstructured data coming in, and unstructured would be everything from video, audio, transcripts, etc. It starts to be a source of events data. So the fact that you can connect your webcam to a local, let's say, vision language model, which automatically detects objects in your video and can send you a message when your cat is moving or whatever in your house, things like that. Then you can start to have these theming systems which mix up different elements, and this is super cool. But you can actually get to a place where it all comes together.
Interesting use case. I did not see that one coming. Uh,
Do you have a cat, Mudit? That's good.
no, but I can imagine where you're coming from. Yeah.
I think in the if you're I think the last 5 days have made a change in how the discussion is also happening, right? Because the release of GPT-4o and uh, whatever the newer Gemini models, and how you see the VLM starting to adapt to camera input, for instance, right?
Hmm.
So there is a case where you're linking the two together heavily, which is the streaming part of the story as well as VLM parts of the story plus LLM part of the story on that side.
Hmm.
But that's a very heady mix now because you're very fat payload working with very fat models, right? So
Yeah.
it's a very interesting mix, and
Yeah. One super cool thing that we're seeing a lot at Pathway is actually having a streaming platform which is running, on CPU and on a cluster, which has to call into local models which do something like this, like transform a video frame or just transform an unstructured message into JSON or something like this, which is usually still on GPU most of the time. So we have these kind of asynchronous callbacks coming in, which complicate the architecture a lot, but which we have to engineer to, because this is what some of these pipelines start to expect. So these mixed systems of data processing are coming in into the streaming world.
yeah,
Interesting.
where the consumer or the data processor will start sitting, I think will start mattering because
Oh.
not everything needs to be then centralized. Then, yeah.
Okay. Hmm. Um, yeah. By the way, we are almost out of time, so we have two, three more questions. Would you like us to pick it, or then we can take it offline? A question to the panel, since it's like you can tell me.
We can pick them.
Okay.
Make Adrian, I think I'm okay.
Yeah, we are okay. We are okay.
Thank you. Really appreciate it. A very quick question, a very small follow-up question, because Jay, mentioned about working with very heavy technologies, that is the first thing that popped up on my mind, is that talking about using GPT-4 with streaming, that's like uh, adding a lot of compute costs and making it at a crazy level. But in the current landscape, where let's say companies using something like a Llama 2, for example, or GPT 3.5, do we still see any use case around generative AI plus streaming? Can you give an example quickly so that it's easy for somebody to think of?
Well,
Anyone, maybe. Yeah.
Adrian, you can go, I
yeah,
think.
one that's much lighter is like automatic extraction of events out of text messages. So if you think that vision is heavy, then you can just take one of those messages that are used, I don't know, in aviation or in military communication or something, and automatically pass what's happening, or a weather alert or anything like that, and just get the facts out of a short text message or a social media post. That sort of thing is something that's happening already, and it's a bit on the lighter side. But already, for in terms of latency, the GPT-4o type of use cases are no longer an issue, in the sense that you can get a reply in sub-second latency, essentially, and this means that you can go really, really kind of big. You can scale up the two parts of the system as needed. The part that's doing this kind of subcontracting for you as an LLM that's integrated into big. So even there's things that can be integrated with streaming architectures, and a part of it is like not to slow down your streaming pipeline when the LLM part is lagging, but still to be able to catch up later. So it gets us into interesting architecture situations.
Okay. Thanks. Yeah, that's an interesting use case. Divanshu, would you like to pick the next question that we had? It's slightly from the data science community as I speak, and it's something that you and I were also discussing. Yeah,
Yeah,
can you pick
sure.
that?
So, elaborating on the use case part, talking about the use case part, we also see that many times when we search on Google about applications of stream data processing in finance, we find that fraud mitigation is a very important use case. Even when we see on Google or even on the Pathways website, we see that stream data processing can be used in fraud mitigation. But how much do you think that is happening in practice, or do you think it's just some bookish stuff?
So, Jay, can I take this?
Yeah, go ahead.
Yeah. So this is not just bookish stuff. I mean, this is happening across the industry, right? And this is, I mean, for financial institutions, right, which need to safeguard the money of their customers and all, right? This is something which is not just a, I mean, fancy stuff. It's a necessity, right? It's something they need to adopt as a practice, right? So uh, a lot of banks and financial institutions are doing it with the real-time data that is coming in. I mean, the training of the models, I mean, that is largely batch driven, but the decision making is, I mean, it happens on the live data, right? And that is also now changing slowly. I mean, with the uh, processing frameworks like Flink and Spark and others, right? That we are also seeing use cases where we are doing the user behavior. I mean, real time user behavior, or not real time. It would be mostly near real time user behavior analysis with with the look back window of, let's say, 24 hours or 48 hours or something like that, right? So uh, building a user profile for last 24 hours or something, I mean, and up to this instant, right? So that is what is helping organizations make their fraud models, or even fraud uh, detection and prevention models much more smarter. Yeah.
Okay. But so I have this question here. Like, for example, you mentioned a couple of things. One is near real time, where you mentioned that,
Yep.
and second, I would wonder that from the angle of fraud, fraud mitigation, it may not be from the regulatory compliance perspective. They won't go and specify whether you should do a batch job or a streaming job. They may say that you
Mm.
might have to put in systems to avoid it.
Yeah. Yeah.
But and then you're saying that it is near real time, so is it really helpful to have streaming in place at all? Because if you're doing near real time, why don't you simply run a batch job and then keep it much more simpler?
See, it also involves, I mean, in what are you choosing to do? I mean, how you are choosing to do it. So, if you are going for I mean, small micro batching, right? That is also, I mean, that can work for you, work for many organizations. I mean, it's not just, there's no standard template to it, right? Organizations take their call accordingly, right? In if you are choosing to do it through streaming frameworks like Flink and Spark, right? And specifically for Flink, right? You are getting the power of maintaining uh, in-memory states, right? For the users. I mean, you are also with pure streaming frameworks like Flink, and I'm not doing an advertisement of Flink here, but with a pure streaming frameworks like Flink, what you can also do is detect complex transaction patterns or interaction patterns between different users, right, in real time, right, and not just looking at the data in a batch form. I mean, you can design complex state machines, state interaction graphs, and all that. So that is what the power of streaming is.
Okay. And given your context, Adrian and Jay, would you like to add anything to it, or we have any contradictions? I'm assuming them would not be, but still.
No, I think you mentioned micro batch, right? But you,
Mm.
if you just play it out, you end up creating like a micro streaming solution eventually, right? The that's the problem there. I mean, you have to figure out horses for courses here, right? So here, for instance, what allows you to get off the uh, street running, basically, meaning I think that's where most of the streaming solutions are handy for you, right? Which allow you to at least engineer these tools. If somebody is looking at fraud mitigation with near real-time approach, you have tools for the job which allow you to get the ball rolling as early as possible, looking at a window which is very close to the current state, looking at signals which are very close to the current state, looking to query those signals, for instance, building profiles over those signals, for instance. All those are possibilities which you can sort of work on. And I think what we feel, Meg, I'm answering for you also. What we feel is how the streaming world allows us to get the ball rolling as early as possible. Right? That's our perspective. I think it's means work uh, as opposed to like a micro batch that we are talking about also.
Interesting. Adrian, would you want to add anything here?
I'm with both of you, and obviously, you're the experts in the field, so it's a pleasure to listen to the perspective. And I have what little we can add on our side is that actually, well, Flink is kind of made to support complex state processing, but then if you pull it off or not depends very much both on you and on Flink. It's a bit it's a bit unpredictable in this space. So I wouldn't like to say whether it works or not. It might work for you, it might not work for someone else. This is one of the topics that actually, when you get into this kind of complex state management, managing graph data in memory, it's a great opportunity for streaming solutions in general. So I think it's something like more data teams should go in this direction. And I would actually say that the problems with tooling are one of the problems that have been holding it back. So as something that we do, we try to do is to try to alleviate exactly those problems with reliability, with consistency, in putting together this type of solution at scale when processing complex graph data in memory. So this is just a perspective that it's the way to go, and everybody has to put an effort in to make it possible. Maybe I could add one thing without, obviously having as profound an expertise in the financial fraud world, something just to make the topic relatable for those of you in the audience who haven't worked with financial data. So two topics that are super cool and that everybody knows about. One is spam. So think about detecting in real time that a new type of like phishing attack has started, how much time you have to react, how you would react, how you design a system to do that. And the other is social media fake news detection. It's also a kind of fraud when somebody starts to circulate fake news and others are picking it up. How much time and how you would react to that sort of thing if you were in, I don't know, TikTok or whoever else who needs to act quickly to detect that sort of trend. So two types of fraud which are maybe closer to everyone, because you've certainly been at the receiving end of it at least once. So something to think about how you design a system in this direction, and maybe related to the streaming discussion.
Okay. Interesting. um yeah, that's an interesting set of perspectives coming in here. In fact, the use cases as well. Divyanshu, would you like to pick the next question quickly, and then we'll come towards the wrapping end here. There are a couple of questions from the audience as well. We don't want to pick a two very important questions, but then yes, Divyanshu.
Yeah, yeah, surely. So we can quickly look on the next question, and maybe you can keep it a bit short as we need to move on to the next questions. So many use cases clearly benefit from streaming. For example, I recently read a paper from Rexis, which is how lower latency can enhance social media recommendation engines. But many companies are still planning on using streaming for this. So, do you anticipate any challenges that the company should brace for, as the challenges which were seen by in companies and which are addressed by the current tools from organizations like Apache, Confluent, Pathway, etc.? So, do you feel like that, or do you feel like there are challenges currently?
Adrian,
So
this is for
I
you.
think,
I think
yeah.
you have heard.
So I actually wanted to add this. So as in one of the questions earlier, I covered, right. So I mean, adopting the streaming data processing is an investment, right? It's a cost. I mean, it's not it comes with its own expense, and that is basically the tooling. I mean, the hardware, the software, and even the people investment, right? So I mean, mostly, as Adrian also mentioned earlier, that for some it is a necessity by which they have to adopt it. For some it is a choice, right? So if you have that choice, it totally depends on whether you want to take that choice or not. But if it's a necessity, then you'll of course adopt it. And as also Jay also mentioned it earlier, that it's a lifestyle, right? So you have to align your teams accordingly. You have to align your resources and everything to support that kind of methodology or process, right? So that's what I would say.
Okay, interesting.
Jay,
Around
again,
the
you guys would want to add anything?
For me, I can tell you just one word about what we were like seeing in terms of uh, also how developers and machine learning folks react to the streaming world. And it's actually, if you think about programming and streaming, it's something that it's like a term which is almost new. It's a bit like what? I mean, streaming is so closely linked in many places to the infrastructure stack that programming a streaming system, starting a streaming project is often a complex endeavor in the sense that it's really, as Meg says it's like an organization change that you have to put the infrastructure up and add the streaming component before you start projects, which are then closely linked to your infrastructure. So it's a bit like you start by setting up a database, and then you write your 4PL code or whatever in it. So it's kind of like building around the infrastructure. Um, we see that there's a big trend, especially among the younger players, to bake with this. We to take this the full way to basically saying that in streaming projects are code. So you can think of more of streaming projects as something that is kind of portable between installations, between systems. Like a GitHub repository that you create and it's your streaming project. But I think a shared goal is to give developers the autonomy to actually program in it, to feel comfortable like you would be developing a local application, to be able to develop code logic in a streaming system and then put it into production easily. So these barriers are still quite significant, and we feel that the existing players must adapt substantially still to allow, especially new organizations who come in with their own needs. So we see a lot, for example, in fintechs, in the companies that are doing cryptocurrencies, etc., that many prefer to build their own stack ground up in Rust or whatever, rather than go for Flink as a choice. And the reasons for it that actually still a lot of these actors are kind of hampered by the lack of infrastructure, which is just not usable for quick development and quick prototyping. So this is one perspective.
Jay, would you like to add anything to it? Like, or you
No,
kind of echo what Adrian and Mick said here?
no, I think I said it earlier. Right? It's a choice. It's a lifestyle choice here. In a manner of speaking, you have to be ready for it. If you are taking a half-hearted step, I think better not take it. I think best is commit to it and go full hog on this, right? And be ready for those parts. Meaning, I think we'll see you basically transforming your organization also, right? Because the nature of those individuals starts changing, because you see people being ready for those streaming challenges as opposed to like a batch engineering challenge, which is very different in nature. The kind of team that you have, the kind of skill sets that they have or they end up having, for instance, will become very, very different. And that's the part that you have to be ready for.
Okay. Okay. Fair enough. We like we understand there are a lot of challenges in this. This overall spectrum is going to evolve quite a lot as we progress in this journey. Do you see any challenges being like? Do you see any crazy innovation or research work that is stemming out of India or in general? And as a follow-up question to it, do you think like Kafka, who's like the king in a way as of now in the streaming space, a lot of people are using it. Do you think it is going to stay, or there are, I mean, players like Pathway who could possibly go and break stuff in the domain?
I think Adrian, you have to answer the challenge to Kafka. So I think we in The interesting mix is the even if you look at the current keywords which are being used around streaming and stream processing and consumption, etc. I think you'll see the top five uh, tool stacks being repeated across, right? The Kafkas, your Flings, your Druids, your Pathways, etc. For instance, right? Uh, the interesting facet is in how people are going about using it. What are the new things which are emerging onto the feature, like querying, which appeared possibly like 5 6 years ago or whatever, on top of a streaming pipeline and stuff like that, which is starting to make more sense and starting to gain more traction there. Uh, and uh, I'm sure this is a question designed for Adrian, but I'm butting in anyway. Uh, but
Would love your perspective on this, by the way.
so uh, but if you look at the recent evolution of all these streaming journey, I think you will see one or two organizations which are leading the pack, especially the ex LinkedIn folks, for instance, who are doing things like Confluent and Pino and stuff like that, right? Uber, of course, and guys like you who are leading the way in some way, uh, in some fashion. So I think more towards this, more towards possibly what the consumption aspect looks like. I think generative AI may have some say in the way people end up consuming stuff, for instance. But general adoption ease is what you're looking at also. Right? There, there's the other side of the mix, which is like media streaming, etc., which is a whole different game. But uh, I think it's still evolving. We'll see possibly in the next 5 years whether we approach a steady state that looks like the tool chain of now, or whether there's a difference of 10 15% from the tool chain of now. Uh, but so far, it's looking fairly stable from a tool chain perspective, with brand new entrants also, but uh, possibly leading the mix, right? Uh, but looking forward to how it plays out in the next 5 years is what I would frame it as.
Hmm. Okay. And Megan, Adrian, how do you look at it? And a very basic question here: where exactly is Pathway fitting in the spectrum? Because we talked about a lot of tools. Uh, where which piece of puzzle is Pathway actually trying to fix? So, Meg, if you could go first, and then Adrian maybe can answer about Pathway and if he feels like his envisioned future around the space.
So I think I don't have any much to add, anything much to add to what Jay has said, right? So most of the frameworks, I mean, there are still a lot of frameworks coming in terms of streaming. Since it's a relatively less adopted practice. I mean, when I say less adopted, it is, I mean, it has been in adoption for last 5 6 years. I mean, heavily. Before that, it was very obscure. I mean, very many. Very less companies were doing it. I mean, LinkedIn and Ubers and all those leading the way. But yeah, I mean, as we go along, people are realizing some challenges that they want to solve themselves, and then spin up a new framework for that. So it remains to be seen what else can be, what else can come uh, in the next few years. But yeah, as of now, I think it's going towards the maturity, is what I would say.
Maturity in terms of
In terms of I mean, the frameworks that exist in the market, right?
hmm,
They are more or less solving the problems that are there related to streaming to a very large extent.
okay, got it. And Adrian, what's your take on this?
Yeah, thanks, Jay and Meg, for these perspectives. And actually, I wanted to anchor on something that Jay, you said before a bit about these ability of streaming systems to also have like queries to them. So what we're seeing a lot, and this is like a very, very broad perspective, is that there are two like paths of acting on data. There's what's known as the write path when you're writing data in. So you work with data that's flowing, and the read path when you're querying it, when you make queries to data. And again, it's a decision of every organization how much of this write path they invest into and how much of the read path they invest into. But actually, both are needed for systems. And it's true that streaming systems traditionally were neglecting the read path, the part about like querying, accessing it, etc., which made it harder to put into place systems which were needed for operational analytics and so on. So this is a big evolution, a big direction, which we see investment into all around. And Pathway notably also comes into this direction as a data processing technology, which makes it easier to transform data on the right path and to access it, to grab it, to collect it from different sources, and to push it out into different sinks and to query it. One point maybe which is super interesting is around the fact that there's more and more systems which actually need both of these paths. And like we mentioned RAG around LLMs, and it's super interesting to see the opposite perspective, that in fact RAG systems are systems which also have like both paths, the write path and the read path. And if you look at how the actors in RAG and LLM are looking at it, they're mostly looking at the read path, which is about querying data, but not so much about the part about data indexing, keeping it up to date, interacting with data sources, and so on. So there seems to be some kind of like shift in the opposite direction there, and the ability to somehow combine and work together make the two paths, the write path and the read path, work together is still a goal that Pathway is striving to achieve, and a lot of the other actors there are kind of trying to combine technologies as well and wrap it up and make it possible to achieve this combined goal. And when maybe one final point, because Divanshu and Mudit, you asked whether Pathway is trying to replace Kafka. So Pathway is kind of happy to work with Kafka. We have a data processing technology on top that can replace Kafka streams of Flink in this setup. But then again, we if sometimes we talk to new users who are asking, should we adopt Kafka for pushing our data through the systems? And very often the answer is you can if you like it, but you might just as well be using, let's say, high throughput, low latency versions of S3, of other data storage, which are more like files that can be accessed super quickly. And it gives you a kind of streaming like system, which in fact you can work with data processing anyway, and as if you would be in a streaming system, while you have this kind of look, which is more like a data lake. So you can create a kind of streaming system which in fact does not use Kafka, which relies on bucket storage or on other architecture primitives, while transforming it in the same way. So you can use Pathway with Kafka, you can use Pathway with S3, for example. So it's kind of the same kind of thing. And it's from our perspective, it's interesting to see which of these approaches will win, which will prevail in the long term, because it's not entirely clear like which use cases will be more naturally in which bucket sometimes.
Okay, thanks for answering this, and we have massively overshot the time. So thanks a ton, Jay, Adrian, and Meg. Maybe in a rapid format way, we can take two questions that have come from the audience. One is, this is something, by the way, because part of multiple groups with multiple IITs, and when we shared, the immediate question was, is NPCI and Pathway hiring interns? And there's a question around these lines, in the comments as well. Can we IIT Bombay students with work on it or join Pathway? And even actually general question, sorry. How can IIT Bombay students get the opportunity to work with you? So maybe NPCI and Pathway, quick answers from your end.
Yes. So I think there's no doubt about that. I think we're always looking for very interesting and talented interns, talented folks who can contribute to data engineering in a huge way. And the way we work is also very interesting, right? We generally work with folks like Meg, for instance, will be guiding them all along, allowing them to see a real world perspective of how things work from a pure data engineering perspective.
Awesome.
So definitely welcome here. So I think this is always on
But
our minds.
the interns working on data engineering spectrum as well, because a lot of students take a relatively bit more time to, like, they don't spend a lot of time around data engineering in their academic years. Do you have interns in that domain as well around data engineering?
Yes.
Okay,
Yes, we do.
nice, awesome. That's a very clear and straightforward answer, and in a way, encouragement to go and apply for sure. And Adrian, would you like to answer that quickly?
Yes, absolutely. Likewise, we always don't want to be in competition with NPCI, but we're always also looking for amazing people, amazing interns. We have a couple of internship offers that are regularly published on the website, but there's some other opportunities that are not published and that I can mention. So if you have ideas for projects which you could deliver, like open source projects that you'd like to create using Pathway, we are more than willing to sponsor them, in some cases to guide them, in some cases financially, in some cases both. So just don't hesitate to reach out. If you feel that you still need to learn a bit, then I leave to Mudit maybe to say a word about some of our activities around boot camps to help guide into the streaming world, the RAG world, and Pathway and similar technologies.
Yeah, I'll quickly summarize on that front. We do conduct, so the kind of school of thought we come from is, interestingly, a lot of people at Pathway have been professors themselves. So it was very intuitive for us to go and work again, give back to the academia. And that's when even I would say folks like Jay, Meg, everyone have been super kind to be very proactive and contributing. So Jay took a session, for example, on end-to-end RAG, which is a very prevalent and very relevant thing to talk about. So we do have a few resources that we have published. You will find them on Pathway's website also as very well soon. And some academic institutions in India are already going and running these in a cohort-based manners. So we have one coming up with the IIT Masra very soon. So, and there's one running with IIT Delhi as we speak. So yeah, and this is a session in fact with IIT Bombay. So these all are learning opportunities in a way. Another quick question here is this is a very small question, like which is from Abhijit. So regarding real-time data accuracy, since the question is a bit open-ended, do you, if I have to restructure it in this format, do you think there's some, this is as open-ended as it gets. Maybe if you want to share your interpretation or try to quickly answer this, by the way.
So I think the question is more around whether the data that is ingested through streaming processing, right, or the real-time
Hmm.
methodology is it accurate, right?
Hmm.
So that actually depends on the kind of I mean it's basically an iterative process, right? So when you start doing it, right, you might see that there are some challenges in the accuracy of data. Then you need to debug them. You need to see in which because there can be some silent failures happening in uh, the pipeline that you have built, right? So you need to work towards the fault tolerance of your pipeline, right? So cover more edge cases, more scenarios in terms of data quality and all that. And then eventually you might be able to get where you can see zero data loss, or I mean the complete 100% accuracy of your data. So it's an iterative process. I mean, it's not a you some if you are lucky you get it right in the first time, but not I mean not everyone is lucky, and you usually have a lot of learning along the way. I mean, you get to learn a lot about the internals of the framework that you are using, the system that you are using, and even what all considerations you need to have when building a pipeline, because I mean, building a pipeline is not a one-time job. You have to, you need to build a lot of things around it to support it running continuously, support it to run continuously, to ensure that uh, it is processing the data correctly and all that. So yeah, that is my perspective on this.
Okay, cool. Thanks. And with that, we would probably wrap this now because I just struck me. I should check my WhatsApp DMs if anyone on the panel has prompted me that it's already been very long. And I'm superly thankful actually that all of you have been super kind enough to pick questions across the domain. And I think we will also, these recordings are already accessible on YouTube, LinkedIn, and all. Um, we'll also try to draw some insights out of it and put it in a blog format so readers can benefit from it too. But thanks a lot, Jay. Thank you so much, Adrian. Thanks a ton. We superbly thankful that you took so much time to kind of process a relatively very broad spectrum of questions and then answer them for the audience also. Thanks a ton for that.
Thank
Thanks
you,
for
brother.
hosting us for
Thank you
this,
so
Thanks
much.
to you.
Divyanshu.
Thank you,
Thanks.
Jane.
Surely, thanks a lot from WNCC side as well. Got a lot of insights, and I surely think that the students would have benefited a lot from this. Thanks a lot.
Good to know.
Thank you.
Thank you
Thanks,
so much, everyone.
Thank
Adrian.
Thank
you.
you.
Thanks, Jay.
Have a great
Thanks all.
day.
Bye.
Bye.